Welcome back. We're going tonight to solve systems of equations with substitution. If you look at this first problem, this is a y and this is a y. So since in the first equation y equals 3x, I can substitute 3x in for y and solve my equation because I'll only have one letter. So instead of y, I'm writing 3x. So I have put those two equations together through substitution. This simplifies into 5x equaling 45. So to isolate the x, we would divide by 5, and x is 9. Now, the solution of these two is an ordered pair point where they cross, because essentially one of them has a slope of 3, starting at 0. And then this one, you have to kind of think of it as y equals. So this one starts at 45 and has a slope of -2. So they're going to cross somewhere, and that somewhere is over here at 9, and I need to figure out which height. That's the only point that you can plug into both of these equations and have it work. So I'm going to take 9, and I can plug it into either x. In fact, let's plug it into both to make sure that we have the right answer. So y equals 3x, but x is 9. And 3 times 9 is 27. So our ordered pair solution is 9, 27. That point would be up here at 27. Now if we plug it into the other one, also, just to be sure we're right, 2 times, and then I'm putting 9 in for x. Plus y equals 45. So I have 18 plus y equaling 45. So if you subtract 18, that would be 27. So that's fabulous. We have the same answer, and we're going to move on. In the next one, there's one letter that's alone, and that one letter is x. So we're going to isolate that letter through subtracting 4y. So I'm going to rewrite this as x equals -4y plus 1. I always write my letters first. And now I'm going to substitute. This x right here is no longer going to be an x. It's going to be a 4y plus 1, because that's what x is equal to. So I'm going to rewrite this whole equation, 2, and then instead of x, I'm writing -4y plus 1, and then minus 3y equals -9. Now I have one equation with one letter that I can solve. So I'm going to distribute. So -8y plus 2. I'm going to make this plus a -3y. So that's a -11y. These are on the same side of the equation, so I just put them together. Now I need to move this 2 to the opposite side of the equation, so I'm going to subtract 2. So -11y equals -11, therefore y equals 1. So you're going to pick your favorite equation, plug it back in. It doesn't matter which equation you use. You're going to get the same exact answer. So if I plug it into the first one, x plus 4, and then instead of y, I'm plugging in my 1 equals 1. So x plus 4 equals 1, so x would equal -3. So my ordered pair solution is -3, 1. And you might just want to check yourself. This equation right here, if I rewrite it, I can test by putting my -3 in for x and my 1 in for y. And if it works, I know I did it right. So 2 times -3 is -6. 3 times 1 is 3. And that is, in fact, equal to 9. So I know I'm right. So that's for sure my right answer, the one point where those two cross. All right. In this one, that y is already alone. So in order to substitute, we have to solve for a letter. So we might as well solve for that lone y through subtracting a 5/2 x. So I'm going to rewrite that first equation with y isolated. Now this y is no longer going to be a y. It's going to be what y is equal to. So I have my 5x plus 2, and then instead of y, I'm substituting in negative 5 halves x plus 4 equaling 8. Now before we do anything, we need to distribute to get rid of the parentheses. So 5x plus 2 times negative 5 half is a negative 5x. And then 2 times 4 is 8. So this is ironic. These two numbers cancel. They're on the same side. So you do exactly what you do to solve this. So I have 8 equaling 8. 8 always equals 8. So since that is true, this is all solutions. That means I can pick any number and plug it in, and it'll work. And the reason that works is because if we multiply this whole thing by 2, then 5, this simplifies if we distribute the 2 to 5x plus 2y equals 8. So any ordered pair that makes x work will make y work. So it's not just, it's all solutions that make that work. The solutions that make this work are 0 giving 4. That'll work for both. If we plug 1 in, that's negative 2.5 plus 4, which is 1.5. So all solutions that work for the one equation will work for the other equation because they are the same line. Like you can't just plug 0, 0 in. You have to plug a solution for the one. All right. This time it's not exactly the same. If you multiply this by 2 to get rid of that fraction, we would have 3x plus 4y equals 22. And this one is 3x plus 4y equals 16. So let's go ahead and solve the substitution and see what happens. I can solve for the 3x and substitute that whole thing in. So I would subtract 4y. You could also solve for 4y and plug that whole thing in. So since 3x is negative 4y plus 22, I can plug negative 4y plus 22 in for 3x. And then I'm just writing the rest of my equation. So I get my y's to cancel, they're on the same side, and 22 equaling 16. Now that is not true. So this is no solution. These are parallel lines. They both have a negative slope that will never touch, that will never have an intersection, that will never be the same point. The other problem, if you want to go back and think about what that would look like, if I can get back there, this equation, these two lines are literally lying right on top of each other. That's why every solution for the one line is every solution for the other, if that makes more sense. All right, we're going to write two equations now. The bakery sells peanut butter at $6.50 per dozen and chocolate chip at $9. So I'm going to put $6.50 for peanut butter and $9 for chocolate chip. Yesterday, the bakery sold 85 dozen more peanut butter than chocolate chip. So that would mean that if they sold 85 more peanut butter than chocolate chip, that would mean that the chocolate chip plus the 85 would equal the peanut butter. Or you could do peanut butter minus 85 equaling the chocolate chip. It's the same equation. And the total sales were $4,055.50. So that would be the equal sign for the top equation here. All right, so I have solved for peanut butter. You might have solved for chocolate chip. But since I solved for peanut butter, I'm going to put that right there in for peanut butter. Substituting it in. So $6.50. And then instead of peanut butter, I'm putting chocolate chip plus 85. And if you would rather just use one letter, that's totally fine. I like to know what my letters mean. Okay, so we have $6.50 times the chocolate chip, plus, you might want to grab a calculator or just follow me. 85 times 6.5 is $552.50, plus 9 chocolate chip, equaling $4,055.50. So, I'm going to subtract that $552.50 with a calculator, and I'm getting 3,503 equaling, and then I'm going to put my like terms together. 9 plus $6.50 is $15.50. Alright, so to solve for chocolate chip, I would divide by $15.50, and I get $226. So I have 226 dozen chocolate chip, and then I need to find my peanut butter, and this second equation is way easier. So if I just take that number and subtract 85 for peanut butter, I get 141 dozen cookies. So that's my ordered pair solution. Alright, a lab needs to make 1,000 gallons of a 34% acidic solution. The only solutions are 25% acid and 50% acid. So how many of each gallons should be mixed to make the 34% solution? So if I have my X solution and my Y solution, I need to have 1,000 gallons total. So I'm mixing a 25% solution, I'm not sure how much of that, and a 50% solution, not sure how much of that, to get 34% solution, 1,000 gallons of that. So I'm going to simplify the second equation because there's a bunch of decimals. If I multiply this out, we get 340. And this should actually be a Y. And then we're going to multiply this whole thing by 100. So 25x plus 50y equals 34,000. All right. Now, in my first equation, I have x plus y equaling 1,000. So I'm going to solve for y. It doesn't matter what you solve for. So I'm going to plug that in for this y. So if I rewrite 25x plus 50, and then instead of y, I have negative x plus 1,000 equaling 34,000. All right, so 25 plus negative 50 plus 50,000 equals 34,000. So I have a negative 25x, putting my like terms together, subtracting 50,000. So my negative 25x will equal negative 16,000. And then if you divide by 25, you get 640. So I have 640 gallons of my x is my 25% solution. And then together they were 1,000. So if you do 1,000 minus 640, you get 360. So then you have 360 gallons of your 50% solution. All right. I think we will Alright, I'm going to start you off. You're probably hearing yourselves in the background here. So these are the two equations that you're going to see where they intercept and then see which one is cheaper when. If you want to pause, you can keep going and I'll keep writing.